Hi everyone, welcome back. In this video, we're going to take a look at systems of equations. We'll continue to look at ways to solve systems of equations. Specifically, we're going to look at using substitution to solve systems of equations. Okay, so in our previous video, we looked at systems of equations. We defined what they were, more than one linear equation, and we talked about solving by graphing, which again just means that we graph both of the lines, we find their intersection point, and that intersection point is the solution to the system. Today we're going to talk about another method that we can use called substitution. Graphing can be useful, but there are situations where graphing might take a lot of time. Maybe the intersection point is really far away from the origin, so it might take a while to graph them and find that intersection point. There are also situations like the one that we see here, where the intersection point isn't very clear. So on the left there, we have two linear equations, a system of equations we're being asked to solve. And on the right, I've graphed both of them, and we can see that they do intersect right here. But it's not really clear exactly what point that is. It looks like x is maybe 2.5, y is maybe -1.5 or so. But because our scale is only by ones, it's not exactly clear what point that is. And it also makes it more difficult if we don't graph it exactly. So if our line isn't exactly straight, for example. So instead of solving it by graphing, we're going to use our other method, substitution, to solve this system. Substitution uses the equations themselves to solve. Okay, substitution involves two steps. So first we want to isolate a variable in one equation, to make sure that a variable is by itself on one side. And then after we isolate a variable, what we're going to do is replace that variable that we isolated with what it's equal to. And we're doing that in the other equation. And replace, another word for replace is to substitute. Hence the name substitution. Okay, so specifically looking at this example, as you can see, we have y equals 3/2 x minus 3. We have already isolated the variable y. So in this case, sometimes you'll be given an equation where a variable is already by itself on one side. In this case, y is by itself. So we're done with step number 1. And then we're taking a look at step number 2, y equals -2x plus 3.5. We see that in our first equation, we isolated y is equal to 3/2 x minus 3. So what we're going to do is replace y in the other equation with what y is equal to in our first equation. So we know y is equal to 3/2 x minus 3. What that means is that we can take y, and instead of writing y, we're going to write 3/2 x minus 3 on that left side. And this is helpful because now we have an equation, you might notice, where we only have one variable, and that's x. So what that means is we can use what we know about solving equations to solve for x and find out what x is equal to. Let's go ahead and do that. So first, let's add 3 to both sides. So 3/2 x equals -2x. Sorry, this should be 3/5 x. Made a mistake when copying down this problem. But that's okay. It doesn't change any of the work that we've done so far. 3/5 x. And you can see that on our graph. We go up 3 to the right 5. Okay, 3/5. Okay, so again, we'll start off by adding 3 to both sides. So -2x plus 6.5. And then next, let's add 2x to both sides. So here we have 2 and 3/5 x. We wanted to write it as a fraction, or a mixed fraction, equals 6.5. Another way to write this, 2 is equal to 10/5. So if we add them up, we have 13/5 x equals 6.5. So next, we're trying to get x by itself, solve for x. we can multiply both sides by 5. So I rewrote the left side as a fraction so that we can multiply by the denominator. 13x is equal to, I think this is 32.5. And then finally, we'll divide both sides by 13. Find that x is equal to, and I think we end up with 2.5 if we divide that. And you can use a calculator to help you out too. 32.5 divided by 13. Yeah, 2.5. Okay, so we found that x is equal to 2.5. What that means is that for our solution, so again, looking back at our original task, for our solution, we know that our x value is equal to 2.5. So looking at our point on our graph, 2.5 is, in fact, the x value for this intersection point. Okay, we have to be careful here because we are not done with the problem. We were asked to solve this system, which means find the point or find the x and y value that is a solution for both of these equations. We found the x value. Now we still need to find the y value. We can do that by taking our x value and then plugging it in to either equation. It's up to you which one you want to use. Either equation will end up with the same y value because it's the same point. In other words, it's a point that lies on both lines. So let's take our x value, 2.5. Let's plug it in to our first equation. Y equals 3/5 x. Instead of x, we're putting in 2.5. Minus 3. Okay, 3/5 x minus 3. All right, so we'll take 3/5 multiplied by 2.5. We end up with 1.5 minus 3. And if we subtract those, we get negative 1.5 for y. So just plug in the x value that we found, and then we can find our y value. In some situations, we'll find the y value first. That's okay. Then we just take the y value and plug it in and solve for x for one of the equations. So our solution is x equals 2.5 and y equals 1.5. Another way to write our solution is 2.5, comma 1.5 as an ordered pair, an x and y value. And if we look to the right on our graph, it looks like this makes sense, 2.5, negative 1.5, because our intersection point lies right around at 2.5 for x and negative 1.5 for y. So again, we isolated variable. We already started off with an isolated variable, and then we took what that variable is equal to and substituted it into the other equation, solving for x, and then we plugged in x to find y. Okay, let's take a look at another example. So here we have another system of equations, and we're going to take a look at solving this using substitution. Instead of graphing, we're using substitution. Here, unfortunately, our first step isn't done for us. We need to work to isolate one of the variables in one of our equations. It doesn't matter which variable you isolate or which equation you choose. Sometimes it might be easier to work with a certain variable or a certain equation depending on what's divisible. Let's take a look at our first equation, and let's isolate for x to start off. So 2x plus 3y equals 12. If we want to isolate x, we'll start by subtracting 3y from both sides. 2x equals 12 minus 3y. And then we need to divide both sides by 2. And when we divide by 2, we're dividing all of the terms by 2. So if we're adding or subtracting anything, we need to divide each term separately. So x equals 6 minus 3/2 times y. Okay, great. So we have isolated one of our variables. We isolated x. So what we're going to do is take what x is equal to and plug it in for x in our other equation. So what this looks like is we have 4 times, and then instead of writing x, we're going to write 6 minus 3/2 y. And then I'm writing out the rest of this second equation. Minus 3y equals negative 9. Okay, so now what we can do is we can solve for y. So in this situation, the first thing we want to do is distribute. We have 4 times something plus something or something minus something. We'll distribute our 4. 4 times 6 minus 4 times 3 halves. Y minus 3y equals -9. 4 times 6 is 24. Here what we can do, we can actually just take the 4 and divide it by 2. So we get 2 times 3, or 6y, minus 3y equals -9. Next, we can combine like terms. So notice we have 2 terms with y to the first power. So we can add or subtract the coefficients. 24 minus 9y equals -9. Let's go ahead and subtract 24 from both sides. So -9y equals, yeah, I think it's -33. And then we divide both sides by -9. So -33 divided by -9 gives us 3. If you use a calculator, you'll get 3.66666666, which means we have 3 2/3 for y. Okay, so we have found our y value for this problem, 3 2/3. To finish up, what we need to do is take our y value and plug it into one of our equations, and then solve for x. So let's take a look at our first equation. So taking our y value, 3 2/3. And then for our first equation, we have 2x plus 3 times, and instead of y, we're going to write down our y value that we found. 3 times 3 2/3 is equal to 12. So 2x plus, if we do 3 times 3 2/3, we end up with 11 equals 12. Subtract 11 from both sides, we have 2x is equal to 1. So x is equal to 1/2. Okay, great. So we found our y value, we found our x value. That means when writing our solution to this system of equations, our solution is x equals 1/2 and y equals 3 2/3. So making sure to write down both of those values. And again, we can also write it as an ordered pair, 1/2, comma, 3 2/3. Okay, so in this problem, we started off, just to recap, we started off by isolating a variable x, and then we took what that was equal to and plugged it in for x in the other equation. Then we went through, simplified, we were able to solve for y by simplifying. Finally, we had one variable, so we had to find the other variable by taking our y value that we found and plugging it in for y in one of our equations. Then we just simplify and solve for x. So again, we went through these 2 steps, isolating and then replacing and simplifying to find our solution. Okay, so that's our second method, solving by substitution. We're substituting the variable for what it's equal to in one of the equations.